Hi guys. In the previous video, the audio was off. Okay, so unfortunately the mic was off, and so unfortunately I wasn't able to. You weren't able to listen anything. So I want to remake the circuit all over again because it is already done. But I will explain what was the problem in the full bridge in my previous videos. So basically, when you have a buck converter like this, it is correct to put D and 1 minus D. Because you are driving an inductor, and the square waveform does actually this. In one interval it charges, and the other interval it discharges, okay? And so that's it. And so that's okay. But when you are driving a full bridge, okay, let me draw like this, okay. You cannot put D and 1 minus D here. This is wrong, okay? This is wrong because first, when you have a isolated configuration with the transformer, the duty cycle D must be less than 0.5. That's because on the secondary side, with the rectifier, even the square waveform of the transformer will be rectified. So if you have 0.45, here you will have 0.95, 0.9. So if you have 0.4 as a duty cycle on the primary side, okay, but you have 0.6 as 1 minus D, you're basically gonna have a short circuit on both the primary and the secondary side, and a switching waveform which does something like this. So something does not exist. So the duty cycle must be less than 0.5, and everything must be D, 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 but with proper translation. In my LTSPICE, I showed you how to do it. Okay, I will just comment what I did here. So first, I put the two switching waveform A and B, which generates the correct, which are the correct duty cycle, which generated the correct square waveform with D over Fs as T on. The other B is translated of D over Fs. There is a delay of D over Fs, of course, but you use a parameter called TD not only as a dead time, but also as a way to reduce the duty cycle. How to do it? So basically, there is this equation here. Okay, you have the duty cycle D, which is T on over Ts. Now you see that D prime is equal to T on minus TD over Ts, which in turns is equal to T on over Ts minus TD over Ts. But this is D. So D prime is equal to D minus TD over Ts. This is the equation that tells you that when you put a TD equal to, I don't know, 100 nanoseconds, and the D is fixed to 0.5, you will have D prime equal to 0.475, for instance. I made this calculation on my Excel. So for instance, in the SPICE we have 250 kHz. The duty cycle is fixed to 0.5. The DT is 100 nanoseconds, and as you can see, the equivalent duty cycle is 0.475. If I put 1000, I have 0.25, and as a rectifier, 0.5. The rectifier is double the equivalent because we are in the secondary side. This is just a simple Excel that basically implements this formula here. Let's come back to the LTSPICE. Let's come back to the LTSPICE. Okay. So this is so these are the waveform, and these are the differential forms for the I side. So now let's analyze everything step by step. Here I implemented a full bridge with 100 volts. So let's analyze first the primary voltage of the transformer. In a full bridge configuration, the primary voltage should be between minus V in and plus V in. And the mean voltage is 0. If not so, there's something wrong. Then we can check. Then we can check the low side here. So let's use B2 and the current. Oh, I'm sorry. Okay, there are some spikes, but I don't care so much. This is basically just the current waveform of the MOSFET. Then let's switch in the secondary side. Let's see the V switch. Okay, there are some spikes. I don't know why, but let me just put the volts as like it was before. I don't know, maybe there is just some sort of bug. It's very strange though. Ah, sorry, there is not the ground. Oh, my bad. I don't know what I upload on. Okay, so now. Okay, so now it makes more sense. Sorry, before there was not the ground. Because I was trying to make isolation on the secondary side by putting a 100 ohm, and I forgot to put the ground. So another thing on the primary voltage is that you will actually have an interval like this, okay, which goes to 0 volt, and this interval here is basically given by the time dt, like it is shown here. So as you can see on the secondary side, we have basically 0.9 as a duty cycle because the rectifier doubles the duty cycle, as I said before. And let's check also the waveform current. This is the contrary because of the length equation, so let's put a minus here. It charges during this interval and it charges during the 0 interval, which is correct, like a buck configuration actually should. And the output voltage is 70 volts. The reason is because I have 20 volts as an input, and I have, let me make some calculation. I have the output voltage, I have this duty cycle here, in times this, minus 0.7 times 2, because there are 2 diodes in series, and so I have V out equal to 17.6 on my calculation. And here I have 17.3. Okay, maybe because there is a little bit more drop, but you got the picture. So this is how you drive correctly a full bridge. What I also shown at the end of the video was also how to what happens if you put y minus d here. Like I said before, d and d, 1 minus d, sorry, 1 minus d and 1 minus d to drive your transformer. What happens if you do this? So let's put again the same here, and let's put 1 minus d on the other switching waveform. And let's put, to make it even more obvious, let's put 0.4. At first, you won't notice any mistakes on the just if you just look on the output voltage, because it is still the same, even a bit higher, maybe because the simulation went a bit further than before, because there was not the ground before. But what you should check here is just the switching voltage. As you can see, I do have something strange. I don't have any interval in which goes actually to 0, but I have a basically straight line and no time to go down, if not for this. So you can even see that there is something wrong. This waveform is wrong, okay? Because you're not giving any time to charge and discharge the inductor. So if you see, this doesn't make any sense. This is not correct. So let's come back again to the correct configuration in which there was the D. So these are the waveform that you should expect. Okay, thank you, because now there is okay, so now it makes more sense than before. Even the diode current makes even more sense. Okay, so now everything is correct. I'm sorry guys for the previous video which didn't have the audio. I hope that now everything is clear. Thank you guys for let me knowing me, and see you in the next video.